Hello, everyone. So today I'd like to explain a little bit about how to make an OakVar annotation module. So OakVar, this is the main program of OakVar on the left side. And then OakVar has 6 different types of modules. There's a line between OakVar and Mapper. So in the order of execution, the first one is a converter. And let's say our input file is a VCF file, then the converter will convert the VCF to OakVar's internal data format, CRV. And CRV has a chromosome position, reference allele, alternate allele, and sample ID and tag. And the CRV is fed to a mapper module. We have GenCode. And the mapper module will convert, again, CRV to CRX. CRX is a CRV plus mapping information. So transcript, which transcript and which gene, and the sequence ontology of the consequence of the variant, and amino acid change, cDNA change, etc. Then our main topic of today, annotator. OakVar will feed the CRX to the annotator. You can configure so that CRV is fed to the annotator. But either way, annotator will receive CRV or CRX, and it will generate .var for variant level annotator and .gen for gene level annotator. So it's a file. For example, if we run CleanVar annotator, then if input file name was the input.vcf, then this annotator and OakVar will generate input.vcf.cleanvar.var. BioGrid is a gene level annotator, so it will generate input.vcf.biogrid.gen. Then if we run 10 annotators, then 10 files ending with .var or .gen will be created, and they will be aggregated. They will be combined into .SQLite database file. In this case, input.vcf.SQLite. And post aggregator module will do some analysis with the entire set of the annotated columns. So CleanVar columns, cosmic columns, etc. The post aggregator has access to all those columns, and it can add more columns. So like if we have a module that aggregates the result of other annotators and then do some calculation to create a new score, for example, then that will be a post aggregator creating a new score, one column for that. Then we have the complete SQLite database file for this analysis. And then the reporter module will fetch the data from this database file and generate CSV, Excel, VCF, etc. We have various reporter module. So that's the main flow of OakVar. Our topic is this step, OakVar annotator CRX to .var.gen. In more details, we have the CRX, and the OakVar will convert the rows, each row of the CRX file into one dictionary. So as I said, CRX has chromosome position, etc., those columns. And those columns will be keys. And the values for those columns will be the value for that key. So we have chromosome 1 and pos 9A349, etc. And this dictionary will be fed to this annotator module. And then annotator module will return its annotation output as another dictionary. So in this case, this annotator has only one annotation column called column A. And that column A value for this specific variant is annotation underscore data. This dictionary will be processed by OakVar and written to one of these annotation file for this module. So here we have column 1 and the value annotation data. This is a tab separated file. Now, for this to happen, we need some files. So what make an annotation module? Specifically, what files? So when the OakVar's annotation modules, when we look at them, they are actually a folder. So CleanVar module is a CleanVar folder. And inside the CleanVar folder, we see 3 files: cleanvar.md, cleanvar.py, cleanvar.yaml files. And additionally, we have a data folder inside a CleanVar folder. And inside the data folder, we have cleanvar.sqlite. So that is the database for the CleanVar annotation module. So when an input is given to this CleanVar annotation module, then input variant will be queried against this cleanvar.sqlite database file, and any match will be processed and returned as an output dictionary, as we saw in the previous slide. What are these 3 files? MD, PY, YAML. So MD is a markdown file that shows the information of the module. And that .py file has the business logic. So there's the main Python script that does the annotation. And that YAML file has the specification of the module, including the definition of the output columns. So this is one example. This was made by one of these interns, G. So we have meta-rnn.py, meta-rnn.md, and meta-rnn.yaml. And again, the MD is the information file. And you can see the markdown notation here. And we have .py and .yaml. And in .yaml, there are more information there, but I'm showing here the output columns field. So output columns, and we have name, title, type with hidden description field and their values. But what are essential is the name and title and type. All the others are optional. So for type, we have string, we have int, and we have float. And for the Python side, the annotate method is the main method of all the annotation modules. So here the input data is a dictionary, as I described. And we can see here the return. We are returning a dictionary, and we have transcript score, rank score, pred, all info, and their values. And you see the transcript here is defined in here as one of the output columns. So the score, rank score, pred, and all info are in the same way defined below this transcript column definition. So OakVar will combine the YAML content and Python script and do this conversion from dictionary to this TSV format data. So it will write these files. If you're interested, you can go to this OakVar modules repository and /annotators and /meta-RNN, then you can see the examples. And let's see some examples here. This is meta-RNN, and it's a simple markdown file. This is the YAML file of that. We have title, description, type is annotator, version, data version. So one thing about this version and data version. The version is mandatory, data version is not. If you have any data, meaning any file that you want to deploy with your module inside data folder, then you have to give the data version. But if you don't have any data, if you don't have the data folder itself, then instead of data version, you will give no/data and colon true. That will indicate that this module does not carry any data folder content. Then of course, with no data true, then data source that's not necessary. But with the data version, then you have to put data source here. So the difference between the data version and data source is data source is the source data version, the version by the creators of the source. And data version is our own data. Because the source data can be the same, but when we make data, the annotation data database file, we may select different columns from the source data, or we may have some bugs in our SQLite file and we fixed it. So then we have different versions between data version and data source. Input format, we can give CRX or CRV, and the level here is the variant or gene. So if we give variant, then CRV or CRX will be given as specified here, will be given to the annotate method. If we have gene as the level, then there is another file called CRG that will be given to the annotate method. And the CRG file has only the gene names. So it's for the gene level annotation modules. And then we have the definition of these output columns, as I explained. From here to here, we have table true and the table headers. Sometimes the data is nested. So in this case, the same one variant can map to several transcripts. And for each transcript, the same variant can have a different score for how damaging that variant is to the function of the product of that transcript, the protein. So we can have multiple transcript score, etc. sets. I mean, the set of multiple such pairs for one variant. So those pairs can be grouped into one table. So it's 2D, imagine 2D matrix, and the row each row is for one transcript score, rank score, and pred, these pair. And each column is these separate fields, separate field. But they are for one, the common variant. So if you define this table true and table headers, then the OakVar will recognize this as an object column, and it will do the JSON. It will make JSON string of this data structure. So to the nested list, it will be stored as a JSON string. But then if you do this, then in the Python file, you will have to create that data structure. And so here QR4, well, that data structure is already stored in the database as a string, I guess. So then this Python script didn't do that JSON operation. But if not, then you will do that and then return it. Well, actually, no, sorry. You don't have to do it because OakVar does it automatically. And then we have developer information here, and then tags. So here the tags is you think this annotator is for this kind of categories. So it's about variance, it's about clinical relevance, and literature information is here. Really. Anyway, and then requires OakVar. These are optional. You don't have to do this. And requires, actually this YAML is not correct. Requires, and after that we need to specify what OakVar modules are needed to run this annotator module. So some annotator modules need, for example, dbsnp ID. To get dbsnp ID, we need to run dbsnp module. Then we will add dbsnp here under the requires field. Minify is an optional field, and then release note also. Now let's go to the Python script. It can be very simple. You just import base annotator, and you derive annotator class from the base annotator class, and then you just need annotate method. We see the self-dot cursor here. It's automatically configured. So in this module, when you install it, actually there is a data folder under meta RNN folder. And inside the data folder, there is meta RNN.SQLite file. OakVar will recognize that file and connect to it and set up this cursor. So this self.cursor will be already connected to the meta RNN SQLite file inside data folder. Then you can do the query with this cursor, and then you can return. If there is no result, then you can simply return none, or just do not return anything, then none will be returned anyway. What we can do inside this annotate is not just querying the database file. We can do anything we can do with Python. So we can query a web API to collect data and return as a dictionary. Or we can query some text file. We can load a text file into memory, and then we do the query in memory. But to do that, because the loading is just a one-time process, then we can have a setup method. So we can def setup and self, and then there we can load the text file. and then we can use that inside annotate method. Okay. So going back to here. So please take a look at again. CRX, CRV, or CRG dictionary coming to annotator. Simply return a dictionary. Then OakVar will write these files, and these files will be collected and then used to generate the reporter, the report files.